The ideal goal of a 3D print is to be print in place, so that when it's removed from the print bed it's already complete and ready to use. Often, however, post-print assembly is absolutely necessary for the design, and this can often involve screwing parts together, either to add movement or modularity, or to attach it to an existing object or device. For this, your 3D printed part needs to feature threads which the screws and bolts can then screw onto. There's a number of ways that you can achieve this, so in this video I'm going to take you through what the options are, what the pros and cons are for each, and how to do it. So, let's have a look. The first thing that you might consider is, well, these are 3D printers. The whole point of them is to print whatever you want, so why not just integrate the thread in your design and then have the thread printed directly in your model? Technically you can do this. I designed the Easy Split, a PTFE tube Y splitter that features threads printed directly into it for the pneumatic fittings to screw into. These threads come out beautifully and they screw in perfectly. Even though it can work on some things, such as a replacement dust cap that I recently printed for the valve on one of my car's wheels, if directly printing threads any smaller than that found on my Easy Split, such as those found on the M3, M4 and M5 screws, you can start to run into problems. Whilst the dust cap does work, because of their small scale, the threads aren't perfect. If they were being used in a part where excessive force was being exerted on it, either by over-tightening or pulling it apart, those small threads likely wouldn't hold up. This method also isn't ideal for applications where you're constantly unscrewing and screwing together small threads, as due to their small size, a small bit of wear and tear is going to have a massive impact on their performance. This method can, however, work really well with larger screw and thread size. With its larger size, the wear caused by the usage has a far smaller impact on the performance, and you're also able to print a more accurate thread. In most good CAD software, such as Fusion 360 here, there's great systems built in which allow you to quickly and easily apply the exact thread that you require to your part, so you don't need to worry about designing something like this manually. If, however, you do need to apply more strength to the female thread, you can put a hole in your model around 0.2mm larger than the diameter of your bolt, so the bolt can just go straight through your part, and then leave a cutout so you can insert a metal nut into the opposite side of your part to where you'll be screwing through. If you are using this method, make sure that when you're designing your model, you're leaving enough space in between where the nut sits and where the base of the head will sit once it's screwed in tightly, as this is the area that's going to provide the strength to stop the nut being pulled through your part. If you do use this method, but for whatever reason you need to remove the nut after you've inserted it, just screw a bolt into the nut from the same side that the nut was inserted, then you can just pull on the bolt and remove it. So that's a useful way that you can solve what may be a pretty frustrating situation to encounter with this method, but it also highlights one of the reasons this method isn't always an option. You can use this method also with smaller thread sizes, but it relies on you having access to the opposite side of your object from where you're screwing in through, so you can insert the nut, and that's not always going to be an option. So with larger threads and bolts, you can either integrate the thread directly in your design and have the thread printed in your model, or you can add a nut to the other side of your part. With a smaller size screw or thread, however, the next option that you might consider is including a hole in your model which is slightly smaller diameter than that of your bolt, and then having the bolts self-tap into your model as you first screw it in. Whilst this can work depending on the size of the threads and your use case, there are three main problems to consider. The first being that when you're first screwing into your object and tapping it, it is applying pressure to your model moving outwards from that hole, and this can result in very fine cracks or at least weakening your object. The second problem is depending on the size of the thread. If it's particularly small, the areas of plastic that move in between those threads and effectively become the female thread may be so small that it breaks almost immediately and therefore isn't holding the screw from the get-go. The third problem I've mentioned before, and this is where if you are going to be repeatedly unscrewing and rescrewing in again, it's going to wear out this thread very quickly and very quickly become unusable. For finer gauge threads which require precision, strength and reliable reusability, the best option is threaded inserts. Threaded inserts are small metal female threads with a grip shape on their exterior. These are effectively melted into your print and locked in place, providing you with a strong and reliable metal thread for your screws and bolts to lock into. There's a huge range of these available, and the design of the grip around the outside of them varies quite a bit. This grip texture is designed to lock your threaded insert in place once it's been melted into your part by having the plastic cool and solidify around it. Some of these grip designs are going to be more effective than others, and some are going to be stronger in different ways. I'm soon publishing a video in which I test all of the common threaded insert grip designs to see which one is best. Until I have those results, my personal preference is usually these ones, but it's not always available in the size you want, and to be honest, for most applications, any of these designs will work fine. To fit them, leave a hole in your model that is at least the same depth as the threaded insert, and between 0.1 and 0.2 millimeters smaller in diameter. Also, leave space so if your screws in past the threaded insert, it's not going to just hit your print. You then want to place a soldering iron on top of your threaded insert once it's in place, so it heats up and melts the plastic around it and slides it down into position. If you find that for whatever reason you need to be able to hold and position your insert until it's entirely inside your print or even deeper, then you can insert it with a pre-fitted screw, which allows you to then hold onto that whilst you heat it up and lower it in. This will take a bit longer to heat up the insert itself, as the heat needs to travel down through the screw, but should eventually work providing your soldering iron gets hot enough. This is also how you can remove a threaded insert once you've fitted one. Whilst you can fit them using a standard soldering iron like I just showed you here, you can also get these special soldering iron tips specifically designed for fitting these threads. They're designed to slot inside the thread, heating them up from the inside out and also providing a flatter base for you to push on them, making it easier to ensure that they go in straight. I'll leave a link to some of these in the description below. Because the insert is going to get very hot very quickly, you don't want to be touching it, so I find that using a pair of tweezers is a good way of holding it in place until it's sliding down into your part. So in short, if you do need to interface with a big chunky bolt and it's not going to have a huge amount of weight and strain put on it, then you're probably best to just integrate the thread into your printing design. And if you do need to add more strength to it, leave space and add a nut. With smaller threads however, especially those that are regularly used or those where you cannot access the back of the part, threaded inserts are absolutely the way to go, giving you a strong and professional finish to your part. Hopefully you found this video useful. If you did, please do mash those like and subscribe buttons. It'll make my day and ensure you get some 3D Rev goodness in your feed in the future. You can also now become a 3D revolutionary, getting a load of bonus goodies including early access to my videos and exclusive access to the 3D Rev Discord community. If you'd like to do that, hit the join button below my video and follow the instructions. Otherwise, as always, thanks very much everyone, and until next time, happy printing. Thanks very much everyone for sticking around. Your interactions and support means so much to me, and an extra special thank you to my 3D revolutionaries for going the extra mile with your support. For now, why not check out one of my other videos, learn something new, or just have some fun. Thanks very much everyone, and until next time, happy printing.